Today we're talking about algebraic properties of equality and congruence. And here on the left side we have a little foldable, and on the front it has the name of the property that we're going to talk about. So we're talking about the addition property of equality. And basically it's exactly what it says there. So if we turn that over, here it says, if A is equal to B, then A plus C is equal to B plus C. And basically what that means is, if we look over here, if we have an equation and we're told that 1/3 of x minus 3 is equal to 2, if we add 3 to both sides of the equation, so if we add 3 to both sides of the equation, that equation will still be equal when we get done. And that's what we've been practicing. That's the same thing we do when we solve any of those equations, inverse operations. So that's the same idea there. Subtraction property of equality, and that's kind of the same thing. If we look at our example, it's basically the same example, but it says if we subtract c from both sides of the equation, it will still be equal. So here we have 2x plus 4 equals 16. If we subtract 4 from both sides, so let's say that this side was a, 2x plus 4 was a, and negative 4 was c. So a minus c, if 16 was b, b minus c, it's still going to be equal. That's all that's saying. And if we look at it this way, it might make a little more sense for us because we've been doing this for a number of years already. And multiplication property of equality, that is going to be the same thing. Again, if a is equal to b, then a times c is equal to b times c. Basically, if we multiply c to both sides of the equation, then it's still going to be the same. So here we have this example where we have 1/3 x equals 5. If we multiply 3 to both sides, our 3's cancel off with x, and 5 times 3 is 15. But this is still going to be equal because what we've done is we've multiplied c to both sides of the equal sign. And here we go with the division property of equality. Again, if a is equal to b and we divide c on both sides, the equation will still be balanced. So here we have 2x is equal to 12. Well, how do we get x by itself? We divide both sides by 2. So that's what the division property of equality is saying. If we divide by the same amount, then the equation will still be equal. Then we have the distributive property of equality. The thing that's a little bit different about this one is we don't have an equal sign here. So on these other ones, we're basically doing our inverse operation. And here we do not have an equal sign, but it says if we distribute properly, so here we have 3 times the quantity 2x plus 4. So if we distribute this 3 properly to both parts of the binomial, both terms, so we have 3 times 2x plus e times 4, that means that is still equal. That hasn't changed the value. Next, we have the substitution property of equality. Oh, I forgot to look at the definition here. Yeah, and basically they just did the same thing for the distributed. They took the A and distributed it to the B and distributed to the C. So we get AB plus AC. Substitution property of equality. If A is equal to B, then you may replace B with A in any expression. So here we have an example. 2x plus 4 equals y. And if we're told that x is equal to 2, we take all the x's out and replace it with 2, which is what we did right here. So we took the x out and replaced it with 2, and that value of that equation is still going to be the same. So here we get into a little bit of geometry here. where previously we were doing a lot of algebra. Reflexive property of equality / congruence. And this is for both. It could be equal or it could be congruent. So, well, this makes sense. If A is equal to A, or A is congruent to A. You could also do it with geometric shapes. We have the line segment AB is congruent to line segment AB. That makes sense. And angle 1 is congruent to angle 1. These things make sense, and remember, it's called the reflexive property. And if we really think about it, reflexive, if you look in the mirror, your reflection is going to be the same as you are. So that's why we're going to call that the reflexive property, because basically it's like the line segment AB is looking itself in the mirror. Then we have the transitive property of equality / congruence. This one's a little bit tricky. The other ones we're pretty good with, and this is one of the ones that we struggle with sometimes. And I'm going to slide it up so we're not looking at two examples. Oh, that example does go there. So if A is equal to B and B is equal to C, then A is equal to C as well. Or if A is congruent to B and B is congruent to C, then A is congruent to C. In the example here, we have shapes. If the line segment AB is congruent to line segment BC, and line segment BC is congruent to line segment CD, notice that this is the same line segment here. So let's say that this was 4 and this was 4. I know we have congruent signs, but let's just say that there's an equal sign there. So this is 4 and this is 4. If this is x, so x equals 4, and let's say 4 is equal to y, well, if y is equal to 4 and x is equal to 4, what we should be able to say is x is equal to y, and they're all equal to 4. And that's all that this is saying here. If x is equal to 4 and y is equal to 4, then everything's equal to 4 and they have to be equal to each other. And then the last one we have is the symmetric property of equality. And this is a little bit different. Symmetric, remember, we're talking about flipping things over a line of symmetry. If A is equal to B, then B is equal to A. So how's this different than the reflexive property? Well, the reflexive property is one thing is equal to itself. So A is equal to A. Here, we're saying A is equal to B. Then we can put B first and say it's also equal to A. We can do the same thing with congruence. A, then B is congruent to A. We can do it with angles the same way. All we're doing is we're switching which one we name first, but it is not going to change the equality or the congruence based on which one's written first. And you guys will have some practice to do with this on your homework. I would recommend starting with this sheet first and then transitioning to your homework from the book when you get done.